Hello students, welcome back to the another video lecture of ADS subject. In previous video lectures, we have discussed about basic of algorithm and mathematics used in algorithm. Here in second chapter, we are going to learn about analysis of algorithm. In it, we will see different performance analysis of algorithms, different types of algorithms, and also the different type of analysis of algorithm. So, first of all, our main question is why we have to analyze the algorithm. So, here as shown in figure, we have a problem, and that problem we are going to solve in different three ways. Means for a particular problem, we are creating three different algorithms. But our main question, main confusion is that out of these three algorithms, which algorithm is the best? So for that, we have to take some specifications, some performances, and based on that, we can conclude that out of these three algorithms, which algorithm is the best. So for a given problem, there are many ways to design algorithm for it. Analysis of algorithm helps to determine which algorithm should be chosen to solve the problem. Now, performance analysis of algorithm. It also known as complexity of algorithm. So mainly, algorithm have two complexities. First one is time complexity, and second one is space complexity. So, time complexity of an algorithm is the total time required by the program to run till its completion. Means total time duration for running a program will be considered as the time complexity of algorithm. Second is space complexity. So space complexity is the total space required by an algorithm to run till its completion. So here notice that space, total space means space in your PC space in your storage space. Okay, so total space will be known as the space complexity of your algorithm. Time and space complexity depends on lots of things like hardware, operating system, processors, etc. things. But we don't consider any of these factors while we analyze the algorithm. We will only consider execution time of an algorithm. For finding best algorithm from given three algorithm, we will consider only the time of an algorithm. To understand this, let's take an example. Here, our example is we have to swap two numbers. Our problem is swapping of two numbers. It can be solved by using two ways. After using third variable or either without using third variable. So our problem is swapping of number and our solutions are using third variable and without using third variable. So these are the two algorithms we can consider. So out of these two algorithm, we have to find here consider execution time of an algorithm. So for this algorithm we have to consider the total time. So for that, here in first algorithm means using third variable, we have declared two variables a and b and also assign value to the both variables. A is equal to 2 and b is equal to 3. Now we have taken a third variable. With it we are swapping our numbers. We have done that t is equal to a is equal to b, and b is equal to t. So our problem is solved, means our two numbers are swapped. Now a's value is 3 and b's value is 2. In second algorithm or second example means without using third variable we have declared two variables a and b. Also we have taken two values of it, a is equal to b and b is equal to 3. Now in that case we have not used our third variable, so for calculation we have done that a is equal to a plus b, then b is equal to a minus b, and a is equal to a minus b. So here again our problem is solved, means our two numbers are swapped. But in first algorithm more space will be required, means we have declared our third variable t, so for storing that third variable our more space will be required. But in our second algorithm means without using third variable our space will be not occupied, so it will take less space. Now main thing is analysis. In algorithm analysis can be done by two methods. First, posteriori analysis, and second, priori analysis. So what is posteriori analysis? In posteriori analysis, algorithm is implemented and executed on certain fixed hardware and software. Then we select which algorithm will take less time to execute. Means we have to implement our algorithms onto the fixed machine or fixed software. Means if we have three algorithms, then we have to implement that three algorithm onto a fixed pc, means fixed hardware or software, and after execution from that analysis we can conclude our posteriori analysis. Second way is priori analysis. So in priori analysis the time of algorithm is found prior to implementing it. Consider this thing, prior to implementing it in any programming language. Here time used is not in seconds or any such time units. Here we cannot take our times into millisecond, microsecond in other time units, but in posteriori analysis we can take our times in second, microsecond, millisecond. So in priori analysis instead of taking seconds in units, we have to present the number of operations that are carried out while executing the programs. In priori analysis, we built an equation that relates number of equation, means number of steps that a particular algorithm does to size of algorithm. We have to find rate of growth from that equations. For example, we have a problem, and for a solution of that problem we have two algorithms, algorithm 1 and algorithm 2. So for solving them we will make a equation from that algorithm. For algorithm 1 we have the equation n power of 2 plus 100n plus 5, and for algorithm 2 we will have second equation is n power of 3 plus 5n. So we will consider on the from this equation only the biggest power number. So from the first equation we will consider n square, and from the second equation we will consider n raised to cube. So if our equations rate of growth is more, then our algorithm will be slow. Consider this thing, if our rate of growth will be more, then our algorithm will be slow. So here in algorithm 1 rate of growth is n power of 2, and in algorithm 2 rate of growth is n power of 3. So conclusion is that our algorithm 2 will be slow. So on basis of it we have to select our algorithm 1. Let's take an example of rate of growth to understand it clearly. So the rate of growth of an algorithm is the value at which running time or cost of algorithm go as the size of the input grows. Means if our input grows, then our running time or cost will also grows with it. So here we have different 6 algorithms and its growth. So for first algorithm, rate of growth is 2 raised to n. For second algorithm, rate of growth is n raised to 3. For third algorithm, rate of growth is n raised to 2. For algorithm, n log n at the base 2. For fifth algorithm, only n. And for the last algorithm, log n at the base 2. So in that our input value is means our n is 64. So our values will be like this: 2 raised to 64 for second algorithm, 64 raised to 3 for third algorithm, 64 raised to 2 for fourth algorithm, 64 log 64 at the base 2 for fifth algorithm, only 64, and for the last algorithm, log 64 at the base 2. After evaluating all these terms, we will check that in the last algorithm, means sixth number algorithm, our rate of growth is only 6. Here take that log 64 at the base 2 means 2 raised to 6. So our rate of growth will be only 6. So we will consider or we will conclude that our sixth algorithm is the faster among the all these algorithm. So we will select our sixth algorithm from it. So this is it for this video lecture. In next video lecture, we will see about the average case, worst case, and best case for algorithms. Thank you, students.